Hello, our team members are Brandon Garcia, Christine Kwan, Bugei. We are presenting on a company called ChemRec. ChemRec is a corporation that develops technology that is used within a craft process in paper mills. Their innovative process is a gasification of black liquor, producing gas and green liquor. The technology boosts black liquor recovery as well as the total amount of energy produced during the pulp process. This is in comparison to the existing benchmark technology, which is a Tomlinson recovery boiler. The key innovation employed by ChemRec is an entrained flow gasification reactor. ChemRec utilizes pressurized substrate and oxidant in high temperature conditions. The process only partially combusts volatiles while producing energy-rich syngas versus solely producing steam. The competitive landscape can be broadly divided into two categories. The first consists of traditional manufacturers such as Mitsubishi, Andritz, and Metso. They manufacture Tomlinson boilers and have the advantage in that they have established markets and reputations, and the boilers that they manufacture have long lifespans. The second category consists of those working on boiler substitutions. On this end, we just have Thermochem Recovery International, which has two commercial scale plants in operations. On the product development front, ChemRec already holds several patents on their unique process. In 2010, ChemRec opened a plant for production of bio-based dimethyl ether from pulp. They've also received a grant to construct an industrial-scale biofuels plant from the Swedish Energy Agency.
Now let's take a look at the general process that occurs inside a paper mill. First, biomass is fed into a boiler to produce energy that powers the pulp mill. Pulpwood is fed into the mill and treated to create cellulose pulp, which can then be used to create paper downstream. ChemRec Technologies hope to increase the economic output of the mill by recycling the black liquor waste product into two useful products, a green liquor that can then be fed back into the mill, and syngas, a precursor that can then be used to create fuels downstream. This is a more detailed overview of the chemical processes that occur. First, black liquor is fed into the reactor alongside an atomizing medium and oxygen, where it undergoes a gasification reaction and decomposes into smelt and raw gas, both of which are then fed into a quench vessel to be cooled by a condensate that is obtained downstream. The smelt is dissolved into a quench liquid to form the green liquor, which is then cooled with a weak wash before being treated with calcium oxide to form white liquor. This white liquor will serve as a sulfur-absorbing agent in the sulfur removal step downstream. Meanwhile, the raw gas continues on to a scrubber and countercurrent condenser, where it is simultaneously scrubbed from particles and cooled before being cleaned from sulfur in a sulfur removal step to produce the final syngas product.
The key innovation in ChemRec's product lies in the gasification process. In goes concentrated black liquor and oxygen at 32 bar and 140 degrees Celsius. It enters through a thermal spray into a 1000 degrees Celsius reactor. Out comes syngas and green liquor. Syngas is a mixture of hydrogen gas, carbon dioxide, and carbon monoxide that's burned as fuel. Green liquor is a mixture of smelts like sodium sulfide and other salts. Black liquor is composed of lignin, which is a complex polymer found in the cell walls of plants as well as other polysaccharides. It also contains ions which are used to treat the pulp. These include sulfite, sodium, and calcium. Looking at the gasification steps, we first start with the dehydration or drying process, which removes excess water from the black liquor before even entering the gasification chamber. Once the black liquor enters the gasification chamber and reaches about 200 to 300 degrees Celsius, pyrolysis begins, where volatile components of the black liquor are released and a primarily carbon char is created. The volatiles start combusting. They produce even more heat, which helps with the actual gasification of the char. The char reacts with steam to form hydrogen gas and carbon dioxide. We quickly equilibrate carbon monoxide and water with hydrogen gas and carbon dioxide. There are many advantages to using a gasification chamber versus a more traditional boiler recovery system. It's a rapid single-stage gasification process. It requires a very low reactor volume because the equilibration happens so quickly. You get near complete carbon conversion as very little tar is formed. And you have a high syngas purity because of the low methane content. With the syngas, you get nearly twice as much energy from burning than you do from the complete combustion of black liquor in a traditional boiler recovery system.